Okay, we'll see now. In continuation with the synthesis of cinchonin and quinidine, the next alkaloid, tryptophan-based alkaloid, is lysergic acid. So here is the structure of D plus lysergic acid, which we are going to, which contains this indole moiety as a basic moiety, and we are going to synthesize this one. So medicinally useful alkaloids, is it plus lysergic acid, which is typically bound as an amide with an amino alcohol as an ergometrine, or with a small polypeptide structure as in the ergotamine. The building blocks for the lysergic acid is tryptophan less the carboxylic acid as an isoprene unit. So here is isoprene unit I have given. So we are going to condense tryptophan plus this isoprene unit C5 containing IPP to give this D plus lysergic acid. Let's see the biosynthesis of the lysergic acid. So it's a quite big biosynthetic pathway. So here we have taken the L-tryptophan, okay, and then we have taken IPP, isopropyl pyrophosphate unit. So we know the how to do the carbocation generation in that one by removal of the pyrophosphate group from the IPP unit. Then reaction of this IPP carbocation generated, that one allylic carbocation, we can react with the tryptophan to get this type of intermediate. Then eventual all this mechanism, that means all this enzyme catalyze all this transformation occurs, and finally we get indole nucleus is a constant, and then again we do get this two 6-membered cyclic rings has been formed on the D plus lysergic acid. Okay, so many different intermediates we do have synthesized here, like phosphoric acid. Okay, so clamoclavin. Okay, so many a lot of this biosynthetic pathway, and as usual we do sometimes we do use NADPH as a reducing agent. Okay, so NADPH is, we know as it is biologically active enzyme, and that one is normally used for the reduction. You can see here aldehyde group got reduced to the alcohol. So like that, just go through this all this pathway. For extra reading, we can take help of the Davic book that I have already submitted to you. Next alkaloid, we can see the camptothecin. Okay, synthesis of camptothecin. So here is slight changes we are going to do. So the basic tryptophan moiety in which we used to see the indole nucleus is present. So now this indole nucleus, beta carboxyl alkaloid, that one is changing from this orientation. So okay, 5-membered nitrogen containing 5-membered has been changed or rearranged to the nitrogen containing 6-membered ring. Okay, so we have there is rearrangement from beta carboxyl alkaloid to the pyrroloquinoline alkaloid. Okay, so this is the basic moiety in case of camptothecin. So camptothecin from Camptothecia acuminata. Okay, um, botanical name is a further example of quinoline containing structure that is derived in nature by skeletal modification of an indole system. So rearrangement occurs. The main rearrangement process is that then original beta carbolin 656 6-membered, 5-membered, 6-membered ring system becomes a 665. Now it has been changed to 665-membered ring pyrroloquinoline by ring expansion of the indole heterocycle. Okay. And this pyrroloquinoline alkaloid, that will be the basic moiety for the in case of camptothecin. So in this biosynthesis of this camptothecin, strictosamide is acts as a intermediate, that one is synthesized from the strictocidin. Okay, so in comparison, the C10 in iridoid portion as seen in the strictocidin is effectively still intact, and is the original ester function is utilized in the formation of an amide lactam linkage to the secondary amide. Okay, this occurs and relatively early, and this strictosamide acts as an intermediate. We'll see now biosynthetic pathway for the synthesis of camptothecin. So here is the structure of camptothecin. Quite okay. So here is our basic moiety, 5 membered moiety, and we are going to synthesize these two new 6 membered rings. And how to synthesize this? This is cytosine. This is our precursor, we can say, and eventual transformation in this one, like lepton formation, oxidation of double bond, aldol type condensation, reduction of carbonyl, then and dehydration. Okay, all these enzyme catalyzed reaction they do occur, and finally we do get the camptothecin as a final product. Okay, so pumiloside is also one of the intermediate we do get, and here our strictosamide is an also active intermediate. Okay, so in this way we can go through all the synthesis of all this tryptophan based alkaloid, and we can take help of our book like Devi book, that is one of the best option to study all this alkaloid.